All right. So this is an extension video. So those of you that are pre-calculus bound, you do need to make sure that you are giving this a look. So here we go. Here's the thing with our log properties. They are actually going to allow us to solve some equations that up until right now, you would not have been able to solve. Take a look at this one, and let's notice how it's different from the ones we looked at in the previous section. And the others, we either had a single log where you could move everything to the other side of the equation and switch to your exponential form, or we had two separate logs, but then nothing else. Here, we have two separate logs and something else, which means it's going to be just slightly more complicated. So here's your choices. We're going to use our properties to make one of two things happen. Thing one, make it so that you have just a single log so that we can then switch to exponential form. Or make it so that you have two logs that are on separate sides of the equal sign with nothing else. And you can actually do this one either of those ways. I personally think it's a little easier to take this one and combine into a single log and then switch to that exponential form. Let's see how it looks. So here we go. We're going to have, I see here two logs are both base 8, fantastic, and oh, there's a minus between them. I know that using my properties, that means I can put these together into a single logarithm where I take what's in the first one on the top and what's in the other one on the bottom. Now you've got a single log. I'm going to put parentheses here just to make it very clear. That's all inside that logarithm. Now, what's inside the log looks a little more complicated, but nothing changes. We've got the log isolated. There's nothing else in front or behind it. You're ready to switch now to your exponential form. So 8 to the power of 1 equals what was inside the logarithm, x minus 6 over x minus 1. Once you're here, this is just a proportion to solve. 8 to the first is just 8. Treat it as 8 over 1, cross multiply, and solve. So I'm going to cross multiply here. So 8 times x minus 1 equals 1 times x minus 6. Distribute the 8. Okay, let's then get our x's together. Whoops, minus x. So 7x minus 8 equals minus 6. Add the 8 over 8. So 7x is 2. Divide by the 7 then. We think x is 2 over 7. Now, what makes this slightly more complicated, because things started with logs, you've got to always check your answers for extraneous solutions. Here's what I mean. So if I use the 2/7, that does in fact make this equation true. This one I'm circling right now in the blue. It does not necessarily mean it works in the original case, because if the 2/7 gives me a negative number inside either or both of those logarithms, then those logarithms weren't defined to begin with, right? So just do a quick check. 2/7 is a fraction that's about 0.28. 0.28 minus 6, it's going to be a negative number. That doesn't work. 0.28 minus 1, that's also going to be a negative number. So this one doesn't work twice. That means that even though we didn't do anything wrong, this particular equation has no solution. Our only potential solution ended up being extraneous. It does not work in the original equation. So in this one, you just got to say, hey, no solution, and then move on with your life. Hey, life, we're moving on. All right, next up. Here we go. We've got another one. I see, 3 logs this time. This is exciting. So this is probably going to be one of those cases where if we get now a single log on the left, a single log on the right, everything inside of logs, we can use that exponentiation trick to kind of make them go away. So let's make that our goal here. On the left, I'd like to get a single log. Now I notice that if these are both log base 9 and they're added together. Adding logs means that you can put the insides together as long as you multiply them. I'm going to put those in some extra brackets just to remind myself that's all inside this log base 9. Next up, let's then, okay, it's log base 9 and log base 9. Let's make both of these exponents on a 9, and then just like plus and minus undo each other, logs and exponentials undo each other. We're going to be left with just the x minus 7 times x minus 4. And then over here, just the 10. From here, I'd like you to do a quick pause. Solve this quadratic equation. Unpause when you are ready to check yourself. So we need to get everything on one side with a 0 on the other. Easiest way to do that, let's first FOIL. So x squared. I keep switching to that skinny blue marker. I like to be consistent. So x squared minus 4x minus 7x is going to be minus 11x's altogether. Negative 7 times negative 4 is plus 28 equals 10. Let's then subtract the 10 over. All right, so x squared minus 11x plus 18 is 0. And then you can factor this one. So let's. Two numbers that multiply to positive 18 add up to negative 11, negative 9, and negative 2. So we've got two potential solutions. X could be 9 or x could be 2. But you're smart enough now to know you got to check these things. Maybe both of them work. Maybe only one of them is going to work. Maybe neither of them are going to work. We got to check and make sure we don't have negatives inside our logs. So first, let's check the 2. 2 minus 7 is negative. 2 minus 4 also happens to be negative, so it doesn't work twice. The 2, not going to work for us. Now the 9. 9 minus 7 is positive 2. 9 minus 4 is positive 5. Okay, those work so far. Those are both going to be positive. Now, it's even better if you run it through a calculator just to double check, make sure it works out. Let's do a little work in our head here, right? If this gives me a 2 and this gives me a 5, then according to my log properties, when the logs are added, I should just multiply those and get the 10. We're in good shape. So in this case, one of the two solutions did work, but it's only the 9. It is up to you to check them both. If you include the 2, you are wrong. You're telling me a number solves the equation that doesn't solve the equation. It's not a small thing. It's a big thing. Okay, let's go one more time. Give this one a shot, start to finish. I won't narrate as I go. We can maybe, we can race each other. Would that be fun? Hopefully you've already started. I'll give you a moment to write it so that you can catch up. And then let's see how things go. Okay, so I'm finished. I'm going to now do a check. So no negatives. And then actually run this through a calculator, do a full proper check. So I think log base 5 of 165 plus 3 minus log base 5 of 3. Okay, and then let's just make sure that that's also log base 5 56. Are they the same? They are the same. All right, so we've done good. That is a solution, and we're good to go. So the checks matter. Use the properties to make your equation a little bit simpler. We've seen that sometimes that means you get two separate logs that you can exponentiate away. Sometimes you get a single log that you can write in exponential form to take care of that logarithm. But make sure you always check your answers. That's a takeaway from here.